Hey guys, it's Al again. Okay, so now that we've laid down some traditional 3D offset pocketing type toolpath on this model, let's take a look at how you can use the advanced roughing with the adaptive toolpath to, kind of cut your part a little bit differently. So there's a couple of areas that we want to look at. The first thing is, in this example I'm using a 1/4 inch end mill and I'm stepping down 100 thou and stepping over 100 thou, okay? And when we look at our tool, we have some, I don't know, maybe kind of crazy speeds and feeds here. 178 at, let's see, a 7,700 RPM, right? Okay. So that's fine. Here's our speeds and feeds. Here's our cutter. Obviously, we could make adjustments with this. We'd probably turn down our speeds and feeds a little bit. That may not be real for this application. I think we have this set to, not sure what material I have it set to at this point. But anyway, so let's get back into our settings here. So we see this is our offset style toolpath. We're stepping down, stepping over. And when we run this through the simulation, I mean, really, what we're doing is taking a shallower shallow depth of cut and a shallow step over, and that allows us to come in and machine this part. So when we look at our ability to speed things up or to cut more efficiently, the next option really is the high-speed options, or what we call adaptive roughing, right? So let's look at what we need to do to turn these options on. So we'll go to our patterns, and we're going to say use adaptive roughing. And then when we go to our parameters, in this case we're going to do twice diameter cutting, okay? So we're going to go 1/2 inch deep, and then our step over, we're going to use 10% of our tools. So we're going to say 0.5 times 0.1, gives us our step over, okay? So we're going to go ahead and recompute this toolpath, and what you're going to see is it's just going 1/2 inch down, and then we have our 10% step over, and it's working its way in. But that's going to do a good job, but there's a lot of material still left on that part. So the next thing that we want to look at is how do we get it to step up, or what we call intermediate steps. And it's actually pretty easy, but we'll run this through, and you can see that we have this tricordial, or smooth toolpath motion to have the tool come in, cut in a single direction, and work its way. We're using a large portion of the flute, but we still have a ton of material left on the part. So the next step that we would want to take a look at is we would come into our step ups, and we're going to set this to 15. So what that's going to do is take the depth of cut and divide it by the step ups to give you your increment of step up. And what this will do is it will come in here and basically re-rough the part, working its way from the bottom up. And you'll see we have a lot more toolpath that is generated. Now, it's very important that we look at this option here for processing. If you're going to use your intermediate steps or your step-ups, you want to make sure, by default it's by area, you want to make sure that it's processing by level so that it doesn't cut a step up out of order. Okay, let me just recompute to make sure. And then now, the other thing is, because you're cutting deeper and you're cutting basically side milling here, you can increase your speeds and feeds, maybe 3 times, 4 times, 5 times. It depends on your spindle range and how many flutes you're working with. And there are some pretty neat calculators that are out there that you can use to help you deal with chip thinning and all kinds of other concepts that have to go along with high-speed machining. So here we're going to just reprocess this through, end with this simulation, so you understand how BobCAD would handle an adaptive roughing in this routine, and allow you to reduce your cycle time and all the benefits that you get from high speed.